This video is brought to you by two Pirates of the Caribbean guys, and I don't know either of their names. Like, I think that's the main character, and that's one of the ship ones. Spoiler alert, I think this one turns out to be the dad of this one or something, like in the very last. I don't know. Okay, so applications, here come the word problems, everyone's favorite. The trick to these, I think, is just making sure you can write the two equations. I feel like the rest of it's pretty straightforward, honestly. Don't worry, it'll get more exciting in 9.2. So here we're gearing up for the holidays. You've got your mail order pet costume company. Oh boy, they ship 120 packages in one day. We charge $3.50 for standard delivery and $7.50 for express delivery. Ooh, that's cheap. On that day, the total shipping charges were $5.96. How many of each kind of delivery was shipped? Notice what we're trying to find. Type of delivery. So let's define two variables. X is going to be standard delivery, and Y is going to be express. So when you're picking your variables for your equations, there's always going to be two, by the way, for these type, you want to look at what question you're trying to answer. Because your variables could be anything we want. So related to this. Okay, so let's say we have X standard deliveries and Y express deliveries. How many total are going to go out in this particular day? 120. Well, we then know that there's 350 for each X delivery, so 3.5X plus 750 for each Y delivery, and that total is supposed to be 596. That's our shipping charges. So all we have to do is solve these simultaneously. All right, which one do you want to do? Substitution, elimination, or graphing, or should we do all three? Great choice. Let's do elimination. So I'm going to multiply this top one by negative 3.5 so that I have opposite signs there. So negative 3.5x minus 3.5y equals, don't beat me by answering that question using mental math. Yeah, 420. That's exactly what I was going to say, negative 420. And then this one, I didn't have to do anything to it. I just copied over. If you had preferred substitution, go nuts. All right, all we have to do is add these two equations together, and we will get the number of express deliveries we mailed out this particular day. Notice 3.5, negative 3.5 added a 7.5 is for Y, and this looks like 176. Oh, okay. So what's 176 divided by 4? If it's not a whole number, then this was a bum problem, right? Because this is the number of shipments. It's not an amount of money. Well, it looks like we sent out 44 express. So how many standard shipments did we send out? Well, just go back to this original equation. X plus 44 equals 120. Solve it for X. That's 120 minus 44. Now, in my mind, if you have this and you're like, oh, look, I just subtract that from 120, you wouldn't have to write out all this mess if you didn't want to. A non-contextualized problem would look like this, but we're interested in the units on these things, not just the pure math. So we sent out 76 standard deliveries and 44 express deliveries. That's what we're interested in. All right, let's do another one. So this equation, well, let's read this. So this is the amount of red meat consumed in the United States, and it's stayed fairly constant in recent years, while poultry has increased. So red meat stayed the same, but poultry has gone up. And if you look at these numbers, that seems relatively true, although there's like a little bit of a dip here, but then it's climbed back up. But those are all right around, that 110 range. Where this goes 60, upper 60, 70, I mean, that's not a huge increase, but whatever. So we're going to use our calculator to find linear regression models, R of X and P of X. We define what they need to be for the per capita red meat R and poultry P for consumption and number of pounds X years after 1995. Note X equals 0 means 1995. So if we go up here, the X values we're going to use in Desmos or your L1, L2, your L1 thing will be 0, 5, 10, and 14. How did I get that? I subtract 1995 from all of these values, and that's one way to get it. Excuse me. Okay, so let's smash this in our Desmos calculator. I prefer Desmos especially for this. So here's my x1. I'm going to do 0, 5, 10, and 14. And then my y values, this one is the red meat, 113.6, 113.7, 111.9, and 112.0. Now, what we want is an r of x thing. So I think the simplest way is to first get the regression equation. So we do y1 tilde. It said linear, right? Mx1 plus b. There's our first equation. And then I'm just going to copy this. So I'm going to go to my little wrench thing. Oh, it won't let me copy that now? Yeah, whatever. Okay, so now we have to make another table. And note, this is now x2. And this is 5, 10, 15, and 14. What? Should have been 0, 5, 10, 14. Boy, I just did this in the worst way possible. So delete, delete, delete. Oh, there we go. Backspace does that for you. And let's type in the poultry stuff. White meat is supposed to be healthier, I've heard. If you're a vegetarian like me, you know that a lot of the fake meats is not healthy. Okay. It's just disease-free. That's, I guess, the main benefit. Y2 tilde M x2, oh, what? x2 plus b. So this first one was to be defined as our r of x, and the second one was defined to be our p of x. Boy, they're not great, right? Look at that. Oh, you know why they're not great? Because I didn't do this one right. There we go. Still not amazing. It's got a 0.7675 as our r squared value, the coefficient of determination. And then this one, oh, this second one is a much better one. But at any rate, let's go ahead and write these two things down. So that first one was r of x equals, okay, now we have to switch screens back. R of x equals, boy, negative 0.141761x plus 113.828. And our p of x equals 0.754176x plus 63.0072. Okay, we're going to come back to this in a second. So this first question says, how can we be sure that these two linear models must intersect at some point? Just by looking at the equations we found. Did you see this? The only time that equations don't intersect is when their slopes are the same. So we would just say they have different slopes. And the fact that they have different slopes also means they're not the exact same line. So not only are these independent equations, it's also going to be consistent. So next, use the functions you found to estimate when poultry consumption will overtake red meat consumption in the United States. In other words, what we're saying is, when is r of x going to equal p of x? Now, I don't like these numbers, right? These are kind of terrible numbers to work with, but Desmos doesn't care about that. It does it really quickly. So I will type in r of x, what I thought I was going to, r of x equals negative 0.141761x plus 113.828. There was our one thing, and then we'll do our p of x. Whatever, you could use different letters here, by the way, if you wanted to, if you prefer the g and f of x stuff. Okay, so our view is terrible, but do you see this little button here? Click that and we get a zoom fit. That was for this one. Click this one, we get a zoom fit for that one. Oh, look at them crossing right here. Here's our estimation. I'm going to write down the solution, and then we'll talk about what the answer actually is. So our x equals, I don't know why you wrote it like this, 56.723 and 105.787. Okay. Note that x was defined as years after 1995. So all we have to do is add this to 1995, and we'll get the year. We'll get the answer to the when poultry consumption overtook red meat, or when will it overtake, maybe I should say. And this is the amount of consumption when they will be exactly equal to each other. So according to my calculator, 1995 plus 56.723 is equal to, okay, 2051.723. So we could say in 2052, they will overtake. Now, you might not remember these extrapolation or interpolation because it might feel like 50 years since we were last in class when we studied this. I believe this was like chapter 2 or 3, somewhere in there. Extrapolation means your equations, your predictor equations, are predicting values outside of the known data set. Interpolation means your predictions are within these known data values. And it should be pretty obvious that interpolation are going to be fairly accurate predictions because it's within these known data values, where extrapolation is not going to be very accurate, especially if we're far from known data values. Our last known data value is 2009. This is extrapolation. Because 2052 is far outside known data values. Why that won't be a good accurate prediction is we don't know if the rate of consumption for either red meat or poultry will continue at the same linear rate for the next, 2020, 31 years. It's really unlikely that will happen. Like you think about what biologists are saying about how half of the planet's half the planet's animals will be wiped off the face of the earth because of global warming. That could potentially have drastic effects on this. Who knows?